Hello and welcome to this SUSECon 23 breakout session on holistic security for Kubernetes with Calico and NeuVector. My name is Leon Barron. I'm a solutions architect with Tigera, and I'm joined by Bastian Hoffman, who is a field engineer for SUSE. Now, the agenda today is that I will go through an introduction to Calico, and then Bastian will go through Calico and RKE2 and Rancher, and then enhance zero trust security with NeuVector. And throughout this presentation, we'll do some demos as well to break up the slides. Now, let's first go through an introduction to Calico. So in case you're not aware, Project Calico is an open source project with a very active user and development community. And then Calico open source was born out of that project and has since gone on to become the most popular container networking and security solution. Now, Tigera backs Project Calico, and Tigera was founded by the original Calico engineering team, and still to this day we're dedicated to maintaining that leading standard in Kubernetes networking and security. Now, Calico has been deployed in large enterprises, financial services, software as a service platforms around the world, and really these figures kind of speak for themselves. Deployed across 2 million nodes, 500,000 clusters across 166 countries. So at this point in time, Calico is very much a tried, tested, and proven solution. Now, a couple of points on Calico. So from a technical point of view, you can deploy Calico in self-managed Kubernetes clusters or on managed Kubernetes clusters. So managed clusters such as GKE or AKS or EKS. And actually on those managed cluster providers, Calico has been chosen as the networking and security provider for those services. So if you were to go to AWS or Google or IBM or Azure, you'll actually see Calico as part of the service offering. Now, Calico has been built on a pluggable data plane model. So that allows you to choose data plane that works best with your workloads. So you could choose eBPF data plane, Linux IP tables data plane, Windows, VPP. And actually, when it comes to eBPF, we are a platinum partner with the eBPF Foundation. Now, if we look at workload interoperability, you may be familiar with Calico being able to secure Kubernetes workloads, but it can also secure non-Kubernetes workloads to allow for that seamless and secure communication between Kubernetes and non-Kubernetes workloads. And when we talk about non-Kubernetes workloads, we're talking, bare metal servers, virtual machines that may exist as nodes inside your cluster, but may also exist outside of your cluster too. Best in class performance. So Calico is going to use the Linux kernel inbuilt, highly optimized forwarding and access control capabilities to deliver that Linux native networking data plane performance, and usually without any encapsulation or decapsulation overhead. And the Calico control plane and policies are optimized for CPU usage and occupancy. So you're just going to end up with a more performance solution with a lower monthly bill. And then finally, from a scalability point of view, Calico is the core design of Calico is based on best practices for cloud native design patterns, and together with very robust and tried and tested network protocols that are used in internet carriers across the world, just results in a solution that's very scalable, has been deployed into production and at scale for years. Now, security policies are at the heart of Calico. And there's a couple of ways that you can deploy those security policies. So first will be policy as code. And what we mean by that is using your existing CI/CD pipeline that you're using to deploy your applications, you can also deploy the security policies that will secure those applications, right? So everything in the same stream. Another way to do this is using the Tigera UI that's available in Calico Enterprise. With the user interface, you're able to create your policies, and you're given quite good feedback to say what endpoints this policy is going to select and to scope. And then the firewall rules, what endpoints are they also going to scope and select? Okay. And then you can do things like preview the impact of that policy before you enforce it in the data plane. Now, also in Calico Enterprise, we've got policy tiers and policy recommendations. Now, policy tiers answer a couple of challenges you may face. One being role-based access control. So what we suggest with policy tiers is to create a security tier, a platform tier, and an application tier. And then you give access to your security team to view the security tier and create policies there. The platform team might be able to see all the tiers and create policies forever. And then the application teams might only be able to create policies in the application tier, and then even only policies that are tied to certain namespaces. Okay. The other challenge that we address here is being able to define certain policies at certain stages, at certain tiers. So instead of having just one big long tier with hundreds or thousands of policies, you can create your cluster-wide policies, for example, on the security team. They may be interested in that cluster-wide security domain. And then the platform team might be interested in DNS policy or ingress policy. And then the application team obviously is interested in the application policies. What's nice here is that because policy processing flows from left to right through the tiers, any policy in a very high level tier like the security tier, any policy that's created there is not going to be able to be circumvented by any policy that's further down the tier. So you're very much funneling that traffic, creating your high level guardrails so that the other tiers can circumvent those security policies that you've created. Now, policy recommendation, as we kind of shift left methodology and we're asking for developers to create more policies, we kind of want to enable them to do that in as easy or an automated way as possible. And that's exactly what the policy recommendation does. So what the policy recommendation is going to do is allow a user to just click recommend me a policy. They select a namespace or potentially select a deployment in that namespace for microsegmentation. Click the recommend button, and then Calico will produce a policy that is fit for that namespace or that workload. Now, we'll take a look at that in a little bit more detail in the lab as well. Now, zero trust access controls. We discussed a little bit about the security policies. Let's say you're a platform engineer and you've been given a task to restrict egress traffic flowing out of your Kubernetes cluster. Maybe not all pods should have complete access in an egress direction. Now, we just talked about security policies, and absolutely you can use security policies to control your east-west traffic and north-south, and they'll work perfectly because you are securing the connection as close to the source as possible, and that's always recommended. That's going to allow you for the most efficient use of your network bandwidth. But let's say, for example, you needed to integrate to a more traditional firewall, and those traditional firewalls identify workloads with more static network entities such as IP address. IP addresses are very ephemeral in cloud-native platforms. So what Calico Enterprise allows you to do is select those pods that you want to allow egress out to maybe salesforce.com. Funnel that traffic through an egress gateway, and then the egress gateway will funnel that traffic out towards the more traditional firewall based on a single static well-known IP address. And then that traditional firewall can apply the firewall rules based on those IP addresses as it normally would. Now, when you're creating these policies, and especially egress policies to external domains and services, it can oftentimes be easier to create those policies using domain names as opposed to IP addresses. The IP addresses that back those domains and services, they can be ever changing, and it's very much a moving target. So instead, you can create your security policies, and in your policy rules, you can put in the domain and just leave Calico deal with the translation of that domain. And then finally, we've got global and namespace network sets. What these are going to allow you to do is, instead of creating multiple policies, dozens, hundreds of policies, and having your list of domains and CIDR addresses in there in every one, instead you would group all your CIDRs and domain names into a network set and then reference that network set in all of your policies. So it makes for a very reusable resource. And also, if you need to change something, you change it in one place in the network set, and that's automatically propagated throughout all of your policies. Now, let's speak about microsegmentation for a second. So segmentation is going to be the method of isolating workloads or applications based on their function. So you may have a front-end application, middleware application, and a back-end application. And more traditionally, you would have created your network infrastructure to secure that. And you would have assigned static IP addresses or zones to these workloads. And we did that because that's the way traditional firewalls worked. That's how they identify traffic. However, as I'd mentioned, in this kind of cloud native world, that network is very flat, creates a lot of blind spots for the more traditional firewall, and it's just not really a way to identify the workloads anymore. Now, microsegmentation itself is very important, and it feeds into that zero trust model. And the idea is that when there is a security incident and a workload is compromised, if you've got a good microsegmentation strategy and architecture, the blast radius, the lateral movement from that compromised workload is going to be much smaller than if you don't have a zero trust stance or microsegmentation implied. Now with Calico, we're looking at identity-aware segmentation and microsegmentation. And what we mean here is that we're not just relying on IP addresses, we're relying on native Kubernetes constructs such as labels to identify the workloads and then apply security policy to them. And it's not just identity to create security policies, that identity is also apparent in the flow logs. So if you were to use some of the Calico Enterprise observability tools and look at the flow logs, you would see those labels. You would see information such as the source of the traffic's namespace, the destination namespace, more than just your more traditional 5 tuples. Now, Calico can also encrypt in-transit data between pods using WireGuard. WireGuard was chosen because it's quite lightweight and it's quite a performant way of creating those encrypted tunnels without the need for any specialized hardware. Now, WireGuard is very easy to configure in Calico. It's one patch command, and immediately Calico is going to automate the deployment of WireGuard everywhere and create that full mesh in your cluster so that any pod that's talking from one pod to another pod on another node, that traffic is going to be encrypted. And we've seen that this type of security tends to be easier than any type of MTLS alternative solution because you don't have to deal with managing certificates and keys. Now, Calico Enterprise also allows for generating compliance reports. And these reports will be based on workload flow logs and audit logs. And those workloads could be pods, they could be nodes, could be related to namespaces, network policies. And out of the box, Calico is going to provide some inventory reports or some reports. And one example of that would be an inventory report, which reports on your cluster inventory and more specifically, the components of your cluster that are protected by network policy. There's also a report on network access, and that's going to give you information about ingress and egress and MTLS. And there is a network policy audit report, and that's going to tell you about any changes that have happened to your network policies. And then finally, Calico Enterprise is going to utilize threat feed intelligence that's constantly scanning for malicious sources to protect you. And we can also detect unknown threats. One way to do that is that we've created an advanced, neural learning algorithm that detects on traffic anomalies. And if an anomaly is detected, it's going to alert you. We can also do unknown threat detection based on honeypots. And what honeypots are essentially decoy pods that are placed in your cluster. There is no reason for them to be ever contacted, but if you do see something trying to communicate with those pods, then that's a fairly good indication that there is a compromise going on. And then finally, Calico Enterprise also provides WAF capabilities. Now, contrary to what you might think about WAF, which generally sits on the the perimeter of your cluster. The Calico WAF sits inside the cluster and is going to protect east-west traffic at that application layer, at layer 7 between pods. Now, Calico is going to leverage mod security to do that, and that allows us to get rule sets from the most common security threats as defined by OWASP. And that also allows customers to bring their own rule set or to subscribe to rule sets. Now, let's just take a look at a demo to kind of break this all up. So here I've got the Tigera Manager UI. I'm looking at the dashboard at the moment. But what I'm interested in here is protecting an application. So if I go to Service Graph, I can see at a high level all of my namespaces that I've got in my cluster. And I've just deployed a new namespace and a new application called YowBank. Now, what I want to do in this application is I want to create security policies. Now, there's a few ways of creating a security policy for this application. The first way is to talk to the application developer and try to understand the flows that's going on within the microservices. Another way, if that information is not known, is going to Service Graph, clicking on the deployment that we see here, and then looking at the traffic that we've seen in the last 15 minutes. And of course, that can be changed to hours or days. But you can see here clearly from this customer deployment, we have 2 outbound connections, one going to kube system, which is most likely DNS, and one going to the summary pod. Okay, and if we were to click into one of them, it's going to tell us what type of traffic we're seeing. Okay, we can also go to the summary deployment and do the exact same, and we can see here that it's accepting incoming traffic from the customer deployment like we just saw. It's also making outbound connections to kube system, again, most likely that's DNS, and it's also speaking to the database deployment, and that's speaking on this port. Okay, so we've kind of gathered some information, and with that information, we can then go to our policy board and we can create our policies. Now that's quite simple for a small application like we have, but if you've got a larger application with many microservices, that information gathering can be quite time consuming. Now you can see here, firstly, before we go into the policy recommender, I've created the tiers in such that I've got a security tier, a platform tier, and an application tier. The security tier is going to have these global network policies. So it's selecting or it's treating the cluster as the security domain. We've got a quarantine policy that at the moment is not selecting any endpoints, but if we were to label a compromised endpoint with quarantine equals true, then all traffic is going to be denied in and out of that pod. We've got some threat feed, and we've got these high-level guardrails. Again, that's not going to be circumvented by any tier over to the right, any subsequent tier. So let's say we want to create a security policy, and we want to create a security policy just for the summary application, the summary workload. So we want to do some micro-segmentation here. We can simply click recommend a policy, select a time period, and what this time period is going to do is it's going to analyze the traffic that we've seen in the last 15 minutes or last 15 hours or whatever to this namespace or to this microservice or endpoint, and then create a policy based on that. So we'll say 15 minutes, we'll select the YowBank namespace, and I could just recommend a policy based on a namespace, but as I mentioned, I want to do it on the summary deployment. So click on summary, click on recommend, and you can see that it's going to create a staged policy. So that's an audit policy. If we were to stage this policy, we'll just see what is going to happen, what it would do, but it's not actually going to impact the data plane. So we can view this. We can see that it's scoped something in the YowBank. It took the labels for the summary deployment, and it's created some ingress rules to allow traffic from the customer deployment on TCP port 80, and egress direction, it's allowing TCP on port 2379 to the database pod or deployment. So we can stage that policy, and as I had mentioned, once we stage it, it's going to show up here, and we can monitor it. It won't affect the data plane, and then when we're happy with it, we can go and we can enforce it. So thank you for joining me on this part of the presentation. I'll now hand you over to Bastian.
Thank you for this great introduction into Calico and Calico Enterprise and in what it can do for the security and the network management of your Kubernetes clusters. In the next steps, I want to connect this back together with Rancher and our Kubernetes distribution, specifically RKE2, and to show you how Calico and our enterprise Kubernetes management ecosystem can work very nicely together. First of all, Calico is the default network plugin for any RKE2 cluster that you provision from Rancher. You have a choice to choose different network plugins if your requirements are different, but Calico is a very well trusted default. Also, since we're using the Calico operator in the background, all the network settings, all the configuration settings you've seen before, all of that is configurable directly through the cluster configuration. Rancher then takes over the lifecycle management of Calico, so you don't have to care about upgrades. Automatically, with every new Kubernetes version upgrade, there's also going to be a new and working Calico version being deployed. And of course, also it is fully covered with the Rancher Enterprise support. If you now want to get a step further to secure your Kubernetes clusters, I recommend you to also look in our Zero Trust runtime security tool called NeuVector. What NeuVector is doing, it's looking at security for your applications on two levels. The first is your whole supply chain to ensure that all the container images you're producing and running inside of your Kubernetes clusters contain no compliance and security issues. And the second, and even more important thing, is then also to secure your containers and applications during runtime, so that you are sure that even if you have security vulnerabilities in images online somewhere in production, either because they haven't been announced yet or because you haven't patched them yet, that you also have additional controls to limit the network connections, to limit file access, and to limit process executions directly at the kernel and network stack level. Let's look into both of those in a bit more detail. First, let's look at the supply chain security. A typical supply chain for a containerized application kind of looks like this. You have the developer that writes some code, and at some point they commit it to a version control system. Next, there is some kind of CI/CD pipeline that starts to run, that executes some tests, builds a container image, and at some point would push it into a registry. And this is the first point where you can integrate NeuVector. You can directly integrate the NeuVector image scanner into your CI/CD builds. And as soon as NeuVector finds a container image that has just been built that has a known compliance or security issue, the developer will get immediate feedback, and either they'll get an alert and say, hey, maybe sometimes you need to fix something, or you can even make the build fail. If everything is okay and the build passes, the container image is then usually pushed into any kind of private or public self-hosted or cloud registry. And also there, NeuVector can be integrated and configured to continuously scan all your registries and all the images that there are in there, to then alert you also if a new container image, a new security vulnerability or compliance issue has been found in an existing container image. At some point, you want to deploy this container image then also into a Kubernetes cluster. And there are two integration points for NeuVector here. First is the Kubernetes admission control system. Kubernetes has an admission controller where third-party software can hook in, and then every time a Kubernetes resource, like for example pod and container, is being created at the Kubernetes API, this third-party application can make decisions in code to say, yes, this should be allowed, or no, this should not be allowed and forbidden. And NeuVector does that. It has a very nice and easy to use admission controller, and you can create your own rules depending on your requirements to, for example, say, hey, Kubernetes, please do not allow the creation and deployment of containers that already have known security vulnerabilities. Or you can make it even a bit more complex and say, hey, Kubernetes, please forbid the deployment of containers that already have more than 5 high severity security vulnerabilities that already have patches and are older than 7 days. And otherwise, it's okay. You can block the creation of the deployment and the pods and containers, or you can just alert. Both is possible. There are more things you can do with admission control, by the way. You can also completely replace the removed and deprecated pod security policies to restrict, for example, that containers should not run as root or in a privileged mode. And last, NeuVector can then also continuously scan all the container images that are running in production and also alert you if a new compliance issue or security vulnerability has been found out. So this is basically image scanning. And image scanning is important because otherwise your security strategy is basically, if I don't see it, it's not happening, it's not a problem. That's not good. You want to know if there are vulnerabilities and problems in your applications, especially if they're running in production. But scanning images and then patching these problems as quickly as possible is definitely not enough. Why that? It could be that the vulnerability and CVE hasn't been even announced yet. It's a 0 day. Or maybe it was just announced on a Saturday evening and you're seeing it only on Monday morning, and then the 2 days in between, the security vulnerability could also already be exploited. It could also be that there is a patch, but you can't update yet because the development team is on vacation, or you have to update and refactor tons of code before you're being able to upgrade to the newest library version that fixes this code. Maybe it's also not even an issue in a third-party library, but a bug in your code that can be exploited. So you actually have to fix it yourself. There are tons of reasons why you may need to run something in production that has known security vulnerabilities. And you have to deal with this fact. You still should patch it as quickly as possible, but it may not be possible. And that's where NeuVector's runtime security component comes in. And NeuVector is doing runtime security on 2 levels. First, it is trying to protect you against things that are known, like known security vulnerabilities, like a log4shell attack or an SQL injection. And what NeuVector is there doing, it is doing a deep packet inspection, and through web application firewall rules and data loss prevention rules, you can scan all the incoming and outgoing traffic and block things that is already known. That works for any kind of like layer 3 or layer 7 network attacks against like all the OWASP.10. But there could still be things that you don't know about yet, where you can't scan for, or where scanning is just not practical because it's a very sophisticated attack vector. And that's where the zero trust components come in. NeuVector can limit and protect all the network connections, all the network behavior, all the process executions in every container, and all the file access in every container image and file system. And based on an automated learning, it can detect the current good behavior and build up a rule set, and then everything that is not covered by this rule set will be automatically blocked. Zero trust. And these automated rules can then, of course, also be exported and transported as security as code, for example, so that you can learn all these rules in a trusted staging environment and then transport them to a potentially untrusted production environment. Let's look into this in a bit more detail. So here is a schematical Kubernetes cluster. And you can see there are like 2 pods with each 3 containers, and there's tons of traffic happening there. Both east to west, so within the Kubernetes cluster between the different containers with the different pods, and also north-south from the internet or intranet into the cluster and out again. And NeuVector can see all these network connections and protect and secure all of them. It can not only do this on layer 3 and 4 to limit who is able and allowed to connect to whom, it's also doing a deep packet inspection and can scan the traffic and then also limit the protocols that are being spoken on this connection. So for example, if the left pod here is web service and the right pod is a MySQL database, and on the connection in between they are speaking the MySQL protocol, you can limit that on this specific connection only the MySQL protocol is allowed, and not HTTP or DNS. You can also say, I want to have an encrypted connection here, and say this is only allowed to be HTTPS. And because of the deep packet inspection, you can also put web application firewall on data loss prevention sensors on any kind of connection to also optionally scan the traffic for additional network and security attacks, like, for example, the cross-site scripting, log4shell attacks, SQL injections, and so on. On top of all the network connections, NeuVector also sees all the process executions in each container and can limit what processes are being allowed to execute. And then also all the file access, file reads and file writes in every container. And it can also limit what is allowed to be written where and read and access there by the actual processes in the container. And anything you don't want to happen that is not covered by rules will be automatically blocked. So next, I actually want to show you this in a short demo so that you get a feeling about what NeuVector can do there for you. So I've prepared a Rancher here. And before we dive into NeuVector, let's first have a look at the Calico integration into Rancher's cluster management. So if I go to cluster management here, and if I create a Kubernetes cluster with the RK2 Kubernetes distribution, you can see that Calico is the default CNI plugin available here. Security-wise, by the way, there are also possibilities to directly harden the Kubernetes cluster and to switch on project network isolation, which only allows network communication of workloads within the same project by default and disallows by default network communication to workloads in other projects. You also, under add-on config, have the configuration options to change all kinds of Calico networking and security configuration values. Once installed, Rancher will directly take over the whole lifecycle management of Calico. And every time there is new Kubernetes patch version out that you update to, you will also receive the necessary Calico upgrades so you don't have to care about it. And of course, Calico is also fully supported through the Rancher Enterprise support. Let's now look into NeuVector. And for that, I prepared one cluster here. And this cluster has a small web application already inside that I'm going to use for some demos. It's a small microservice online shop with multiple microservices, for example, to power the front end, a load generator, a payment service, a checkout service, and so on. I also already installed NeuVector. NeuVector is within Rancher easily installable through the application marketplace with a couple of clicks. And once installed, I have it accessible here directly from the Rancher UI. If I click on it, the NeuVector UI will open and there is a single sign-on, which means I'm logged in now with the same user and the same permissions as I'm using in Rancher. You can already see the security in my Kubernetes cluster is quite poor. That is because I'm using very old container images, very old OS images, just to show something red. Let's look into the security vulnerabilities in a bit more detail. NeuVector scans all the assets of my environment. It scans the Kubernetes platform. There I'm fine. I'm using a recent Kubernetes version. No problems there. It also scans all the packages that are installed directly on my hosts, on my nodes. For example, here you can see all the vulnerabilities in things like AppArmor, curl, and so on. And for every CVE, you have the standard CVE name, severity, rating, and if there is a patch for it or not. You can also click on each CVE to get to the details to make a judgment. Is this something you have to patch right now, or does it have time until the next scheduled patch run? Under containers, you have all the running containers in my live Kubernetes cluster. So for example, if we filter here for our front end of our online shop, you can also click on it, see again all the vulnerabilities that are in here, inside of the container image running in production. By the way, NeuVector not only scans for vulnerabilities, but also for compliance. And let's maybe switch to another one that should have a compliance issue. This Redis here. And you can see it complains that the home Redis folder inside of the container image has too broad permissions, something we should fix for security purposes. NeuVector also allows you to add all your registries directly to NeuVector so that they are also continuously scanned. All this information is also consumable in nice and shareable reports. So if we, for example, go to our security risk and vulnerability report, you can see all the CVEs in which components and which libraries and which container images on which nodes these are affected. Same for compliance profiles. And of course, I'll also get a notification every time a CVE has been found in you. So let's talk about protecting ourselves against it. Under policy, I have a very similar view with all the running containers and workloads in my Kubernetes cluster. For example, the front end. You can see that the front end is currently in a discover mode. In discover mode, NeuVector learns behavior and builds up automatically rules set based on the behavior it's seeing. That can be process execution, file access, or network access. You can already see like a couple of process profiles being created for the server binary and the pause binary that Kubernetes is using for every pod. You can see a couple of network rules that it detected. For example, that the front end is calling the shipping service and the front end is calling the currency service and so on. But you can see there is no communication from the front end to any kind of external system. So let's change that. Let's go back here in Rancher. Let's go to our front end and let's execute a shell directly in the container. And let's call wget to google.com. That worked. So we got a connection here. And if we now go back to NeuVector and have a look at the process profile rules list, you can see that sh for the shell and wget just was learned that it was executed because we are in discover mode. Similarly, there is now a new network rule that was learned to allow communication from the front end over HTTP to external services. Let's change now the mode. Let's switch this to first monitor mode. In monitor mode, NeuVector stops learning new rules. It will not block anything yet, but it will alert us if anything is executed that is not covered by rules. And let's maybe delete the rule to allow wget. If we go back to Rancher and execute the same command again, everything still works. We can execute the process. We can make a connection. But if we now go to our security events, we can see that we got an alert that wget was just executed. Let's go back and let's switch this to protect mode. In protect mode, also NeuVector is not learning anything new, but now it will not only alert us, but also block anything that is not covered by rules. Again, process execution, file access, and network connections. And if we perform the same command again, we did not restart the container. You can see the process is directly killed. And in our notifications, we now also got a critical alert that wget just has been blocked. We can, of course, review this rule and say, hey, this is a false positive. We actually need this for our application to run. So let's recreate the rule with a click. And we can see it's still working. And let's do the other thing around and let's remove the network rule that allows communication from the front end to external services, in this case, google.com. So this is now removed. And now, if you execute the same thing again, you can see it's not creating a TCP connection anymore. to this external IP address because that connection is now blocked directly on the network stack. And if you go to our notifications, you can see that also we got an alert for that. By the way, all of that is also viewable not only in list views, but there is also a nice network activity graph where we can see our whole environment, and you can see here our front end in green because it's in protect mode, and you can also see this red line here, which means there has been a blocked connection to external, and we can click on it. We can directly see what has been blocked, when, and why. And we also can see that all of our applications here with the red bubbles have known security vulnerabilities. Because we are doing a depackaged inspection, NeuVector can also directly do a packet capture here on the traffic that goes in and out of my pod. Let's try that as a last demo. So here I'm now starting to collect incoming and outgoing traffic. Let's give it like a couple seconds, and this should be already enough. And now I can generate myself a download link. And this gives me a PCAP file, which is a file format that I can open up in tools like Wireshark, where I can see all the incoming and outgoing TCP packages, HTTP calls, and everything. And I can dive into and analyze and do any kind of analysis on where is traffic coming from, do forensics, and so on. So this just scratches the surface. We haven't looked at automations, at admission control yet. We haven't looked at the web application firewall, data loss prevention, logging, and tons of other things that are possible here. If you want to know more details, there is also a detailed selection on just NeuVector at SUSECon at this conference. With that, thank you very much for your attention. And let's go back to one last slide. Yeah, I hope we got you interested in trying out NeuVector, making your clusters more secure, trying out Calico, and improving network management, improving security of your whole system. Thank you very much.